This is a video for section 3.7 on valid and invalid argument forms. So we are going to go through a couple of slides and then finish up the next time we meet. Okay, so we've seen this argument before. This is an argument from Spock, who says, if Mr. Scott is still with us, the power should be on momentarily, and then the power does come on, and then Spock concludes that Mr. Scott must still be with us. And so we can rewrite this paragraph in form of an argument. So let's do that. All right, there we go. So we can think of this statement, Spock's statement, in terms of two premises. And so what we mean by premise is, so a premise is basically a given statement. So a given statement is something that we're going to take as true. It's going to be always true. So he's got two premises, two given statements. The first one is this conditional statement that if Mr. Scott is with us, then the power will come on. So this is we're familiar with this type of statement, is the conditional statement. Then the next given fact is the fact that the power did come on. So we've got two premises, and then therefore, so that word signals that now Spock is making a conclusion. There we go. And so therefore he concluded that Mr. Scott is still with us. And so our goal is to decide whether his conclusion is valid based on the two premises. And so so we're going to learn how to do that in this section. Alright, so let's see. Right. Okay. So first of all, let's define what an argument is. So basically an argument is a collection of statements, so logical statements, and like we said, we're typically going to be we're only going to be working with arguments where we'll have two given statements and then one conclusion. But so any given statement is called a premise, and then a concluding statement is the conclusion. So we've got three statements that make up an argument, and then if we're dealing with a valid argument, that means that a conclusion must always follow from the set of true premises. So if the premises are true, then the conclusion must be true if you're working with a valid argument. But if the argument is invalid, then the true premises do not necessarily lead to a true conclusion. So in other words, if you have an invalid argument, there's going to be a case, thinking in terms of our cases in a truth table, there's going to be a case when the conclusion will be false even when all the premises are true. So that basically is a case when even all the true given statements do not produce a true conclusion. So we're going to come back to that idea because we're going to use it to judge the arguments as valid or invalid. Okay, so let's see. Alright, so let's label, we kind of already started doing that, but let's label the Spock's argument here with our terminology. So, like we said, we have this first statement is the first premise. The second statement is the second premise. And then the word therefore signals that the next statement is the conclusion. Okay. Alright. And so another thing I want to mention here is that symbolically speaking, the way that you can recognize a conclusion symbolically is you're going to see these three dots, like so. So if you see these three dots, basically they translate as therefore. So three dots mean therefore, and they signal a concluding statement. So a statement that's following these three dots is the conclusion. And then this line right here in our argument we'll always separate, just another signal for how to separate the given statements, which are going to be above the line, and then the conclusion, which is going to be below the line. Alright. Okay. Alright. Well, okay, so kind of when we first started this section, we talked about this argument briefly, and we, some of you said that this was a valid argument, some said that it was invalid, but mostly we felt that it was valid. So the way to one way to judge whether argument is valid or invalid is going to have to meet certain forms. And so we have five different what we call valid forms. And so basically the way that we're going to use this approach is that if we have an argument written in English, and then if we translate it into symbols, and our argument translated is going to look like one of these forms, then we'll automatically conclude that the argument is valid, because these are basically our valid forms. So it's kind of standardized forms of a valid argument. Now we also have some invalid forms. So these are our invalid forms, and we're gonna look at them in more detail. So once again, if we take our argument and then translate it using P and Q letters, and it looks like the translation is going to look like one of these forms, then we're going to assume that the argument is invalid. So let's go back to our Spock's argument and see if it matches one of these forms. Alright, so going back to Spock. So here we're going to bring in our translation skills back into play here. Alright, so let's translate this argument. So the first statement, the first premise, once again, these two words, the if-then, should signal to you that you're using an arrow symbol. So this is the conditional statement. And so Mr. Scott is still with us. That's the condition. The power will come on. That's the consequence of that condition. So if Mr. Scott is still with us, then the power will come on. So if P, then Q. So this is my P statement, this is my Q statement. Alright, so that's the translation of the first premise. The second premise says the power comes on. Now, when it comes to these arguments, we will sort of disregard the change in tense, the verb tense. So notice here it says the power will come on. Here the power comes on. So this is future tense, this is present tense. We're still going to consider this our Q statement. So nothing else is going on, so this is just a restating of the Q statement. So far, the first premise is if P then Q, that's how it translates, and the second premise just translates as Q. And again, we're disregarding the change in tense, we're still assuming it's Q. And then we know that therefore translates or looks like these three dots, and then Mr. Scott is still with us. Well, that's just the repetition of P. So there it is. That's our argument translated into P and Q, P's and Q's. Okay, now let's take our translation. So everybody write this down. And let's go back and look at our standard argument forms. Okay. So if P then Q, Q, conclusion P. Alright, and so by the way, these argument forms are also included on your reference sheet, so we can look at the reference sheet. Okay. So once again, our argument was if P then Q, Q, therefore P. That was the translation of it. So let's see. This looks pretty promising. But this says if P then Q, P then Q. So here the premise and conclusions are swapped. So no, that does not match that form. Let's examine any of the other forms. So it doesn't seem to match any of the valid forms. However, if you look down here, the invalid forms, here it is. If P, then Q, Q, therefore P. Because our argument matched this particular form, which, by the way, for the purpose of the test, you don't really need to know the names of these forms, just as long as you know that this form represents an invalid argument. You don't need to know that it's a fallacy of the converse. But so our argument form matches an invalid argument, and therefore we can conclude that Spock's argument is invalid, because basically he's assuming that the arrow is pointing from Q to P as well, but the arrow is only pointing from P to Q. So only if P is in place, then Q is in place. But just because Q is in place, it does not necessarily lead to P being true. Okay. All right. Okay. So. Alright, so the next slide I have is, so we're just looking at just a few examples of valid argument forms. So let's kind of take them, just kind of break them into little details, look at them in a more detailed fashion. Okay, let's look at the first example. So first example, and so what you have in the slide is that each argument is then also translated for you. Okay, and each of these examples represents a valid argument, and so we can just check ourselves. So let's check the translation for a couple of them. So this first example says, if I'm sleeping, then I'm breathing. So because of the if-then, I know it's a conditional statement. I'm sleeping is a P statement. I'm breathing is the next Q statement. Then the next premise is I'm sleeping. Well, that's just a repetition of P. And then therefore, I'm breathing, which is Q. So the whole argument translates into this form. Okay. And so just take a minute to look at each of the arguments and verify the translation for yourself, that it makes sense. So actually I want to look at this one, example 6 in more detail. So example 6, it says, I will go to Publix on Monday or Tuesday. So notice what's sort of being omitted is the fact that the first part, so I will go to Publix on Monday or I will go to Publix on Tuesday. So this is my P statement, this is my Q statement. The connective between them is or, so that's that first premise. Then I did not go to Publix on Monday. Again, we don't care about the past tense, and so that's just the negation of P, and then therefore it's Q. So anyway, so take a minute to verify the translations, and the translations make sense to you. And so all of those forms should also match the valid argument forms. So you should verify that as well. So so each argument that we've translated matches one of these forms, which are valid, and so that makes the whole argument valid. So we also have some examples of invalid argument forms. So again, just read each of these arguments and just verify for yourself the translation, that each one translates in this way, and then also verify that this translation, in fact, matches the invalid argument form. Okay. Alright, so what I'd like for you to do now is, using the extra logic worksheet. Nope. Worksheet. I want you to complete questions 2 and 19. So try those out on your own. Okay. Let's see. So once again, what I'm looking at is this extra logic practice worksheet, and I'd like for you to look at questions 2 So read this argument, translate it, and see which form matches it. The only thing that's kind of a little tricky, so notice some of the translations repeat. Well, actually, none of them repeat. Yeah, so we're good. So always also, in addition to the translation, also make sure that the conclusion is also matched, that you either have a valid or invalid argument. As well as question 19. And that's down there somewhere. There it is. Okay, so same idea. So you've got an argument over here. So translate it using P's and Q's, and then see whether your translation matches any of these options, but then also make sure you match up the conclusion, whether it's an invalid or valid argument form. Alright, so let's keep going. Okay, so another approach that we have, and I'm just going to do a few examples for this one, and we'll continue with this one next time. But so the issue will arise if you have an argument, which we will, where when you translate it, it does not match any of those given forms. So it doesn't match the valid or invalid form. So we have to have another approach to figuring out whether an argument is valid or invalid. And this is basically what we're going to do in that case. So it's just an alternative kind of approach. But the idea, or the process behind this approach is we'll have to use the truth table. So we'll have to build a truth table. And it's going to be a truth table with 3 columns, such that you have a column for each premise. Remember, we're only going to be working with 2 premises at a time. And then you're going to have another column for the conclusion. So that's where that 3 columns comes from. And then, after you build your table, then you're going to look for a case, what we call a bad row in your table. So the bad row is a situation when both of the premises are true. So remember, the first 2 columns represent the premises, and the last column is the conclusion. So you're looking for the case when the premises are true, but the conclusion isn't. So that's what we call a bad row. So that's a sign of a bad argument that doesn't take every true premise, and does not lead it to a true conclusion. So if you have such a situation, such a case, then the argument is invalid. However, if you create the full truth table and there isn't such a row, the TTF, the bad row, then the conclusion is that it is a valid argument. So that's what we'll use. Okay, let's look at an example of that. Okay, so let's go back to our Spock's argument, Mr. Spock. So we already learned that this argument is invalid because it actually translated into a fallacy of converse, I think. Form, invalid form. Yeah. Okay. However, let's also verify that it's invalid using our TTF, the bad row method. So again, what we have to do for this truth table bad row method is we have our truth table. So I'm using, because there's only 2 inputs, the P and Q, we just have 4 rows for that table. Then I'm going to, each premise I'm going to put in its own column. So if P then Q, Q then P. So I've got my premise 1, premise 2, and then the conclusion. Okay. Alright, so let's fill in this table. So the first row, so going back to your basic truth tables, so you're looking at the conditional table. And so the conditional table, if true then true is true, if true then false is false, if false then true is true, if false then false, if false then false is true. So that's just going from the basic truth table. Then for the next premise, it's pretty simple. You're just repeating the values of Q, so which are true, false, true, false. And the conclusion is pretty simple. You're just repeating the values of P. So true, true, false, and false. Now look at your created table And do you see a bad row? So remember, a bad row happens when both of your premises are true, but the conclusion is false. And yes, we do have a bad row. Here it is. And that's what makes our argument invalid. You get the point. Invalid. So this is the bad row. TTF. So if you see a bad row, it's a sign of a bad argument. Now, if I build a table and I don't have this exact row, that means the argument does not have any flaws, and it's a valid argument. Okay. So there we go. So just to review, kind of a recap of what we did. So we created a truth table with 3 columns, and we found the bad row. Okay. So let's look at a more complex example. Actually, in your notes, this example is sort of worked out for you, so I'm going to skip that for now, and I'm going to go on to an example that isn't worked out. Okay. So these are just the instructions for this section 3.7 that are coming from your homework. So basically our goal is to translate the argument, and then we have to determine whether it's valid or invalid. Now, always, when you translate the argument, you should always look at your standard forms, the valid and invalid forms, and if you don't see the form, then you have to use the truth table method. So we'll most likely have to use the truth table method. Okay. So first of all, let's translate our argument into P's and Q's. Okay, so the first premise says, if you go to the beach, then take the sunscreen. So I'm recognizing that this is a conditional statement. So I'm going to use the arrow. And the condition is you go to the beach. That's my P statement. Take the sunscreen. That's the Q. That's the consequence. So if P, then Q. If you go to the beach, then take sunscreen. The next premise says you take the sunscreen. So again, essentially it's saying the same thing that Q is saying. So I'm just going to repeat Q. And, so that's and, it rains. Now it rains. It's a brand new statement. So I'm going to label it R. And then the conclusion is you go to the beach or it rains. Alright. So you go to the beach, that's P, or that's that, and it rains is R. So check for yourself, but if you take this form, this translation, and match it, or try to compare it to any of the valid or invalid forms, it's not going to match any of those forms. So that means we'll have to create a truth table for this argument. Okay. Ooh, so it killed my translation. That's okay. So let's see. Make this smaller. Alright. Alright, so let's fill in our truth table. So again, the first premise, which was if P then Q, will go in the first column. The second premise, which was Q and R, is going to go in the second column. And then the conclusion is going to go to the last column. So you go to the beach or R. So P or R. Okay. So now our goal is to fill in this table. And then in class I'm going to introduce sort of a shortcut to this process, but right now let's focus on kind of filling in the whole table. So let's fill in the first column. So if P then Q. So looking at P and Q, if true then true is true. If true then true is true. If true then false, that's false. That's false. And then the rest are true. The next column says Q and R. So I'm going to join the Q in the R column with and. And I know and is only true when both parts are true. So it's going to be false in every other case. So both Q and R are true, so that's true, and then false in every other case. Okay? And now it's the conclusion. And the conclusion is P or R. And so the or, if either P or R are true, then the whole thing is going to be true. So I see a true, the whole thing is true. I see a true, I see a true. Okay, both are false here, so that's got to be false. I see a true, so that's true. And both are false, so that's got to be false. Alright, now take a minute and see if you see or if you have a bad row anywhere. So notice this is T, T, but then it leads to a true conclusion, so that's good. I'm looking for T, T, but leading to a true conclusion. That's good. So no bad row. Again, the bad row is when the premises are true, but the conclusion is false. That's a bad row. We don't have a bad row. Then our conclusion is that this is a valid argument. So this is valid. So this is a conclusion that's valid, and the whole argument is valid. Okay, so what I'd like for you to try now is I'd like for you to look at your extra logic practice and try to complete question 9. Alright, so question 9 is the exact same thing that we've just been doing. So you have to translate this argument, so 2 premises, 1 conclusion, and try it out. So put in the first premise here, the first premise here, and the conclusion here. Now the only issue that you'll have is that you're going to have multiple operations going in. Wait, no, actually you don't. No, you don't, because if you paint the room with red and green, then no, that does represent multiple statements. If you paint the room with red, that's one statement. If you paint the room with green, that's another statement. So that's P and Q, and both are the condition for R, for looking bad. You're painting the room red, so that's P, and negated R, does not look bad. So the conclusion is you did not paint the room green, so that's a negated Q. So try translating and then filling in this table and see if you can reach a conclusion of whether the argument is valid or invalid. Alright. Now, and so we'll go over those tables in class the next time we meet. And we'll actually also finish up the other, so there's 3 more examples left here, so we'll discuss those in class. Now, for your assignment to post on the discussion board in place of attendance for watching this video, I would like for you to complete in that same extra logic practice worksheet, complete questions 2, 19, 4, and 11. Okay, so you've already done 2 and 19, so all you have to do is just post in the discussion board your answer choice. So tell me what you chose for 2 and for 19, but then also tell me your choices for question 4 and 11. So there's 4 questions for which that you need to answer, and then post those answers in the discussion board by Sunday, October 28th. Alright, thanks for watching.